Okay, most probably I have not scanned. I think so that second model, the small videos I have sent you in the uh, WhatsApp group. Okay, now we'll go as by the camera. I will show you the diagram and tell you the explanation regarding that one. Wait for a minute. Can you see the diagram? Can you see this diagram, Sanket? संकेत डायग्राम दिसालाय. Okay, wait. Now दिसालाय diagram. Okay, so this is a Cupola furnace. Okay, now you're seeing no Cupola furnace diagram is there. Okay, huh? हाँ. 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 बरं ठीक आहे. कमेंट मध्ये हे कर, मी पाठवतो डायग्राम तुझा एक. काय ग्रुप मध्ये घाल. प्लीज सेंड मी द इलेक्ट्रिकल आर्क फर्नेस कॉपी म्हणून घाला डायग्राम. नोट्स मी घालतो. हां. हॅलो रवी. ओके, स्टार्ट करो. हेलो संकेत. Okay, can you hear? Okay. So see, this is a simple cupola furnace. For the exam point of view, it is very important furnace. Okay. विचारलं तर it may be asked for the 10 marks if they ask for the exam. Okay. 5 to 10 to 15 marks they may ask, because it is it's having more explanation. It takes more time and simple one it is, and for this it is taking a more marks also. Okay, so this is a cupola furnace which is most commonly used in almost all factories. Okay, nowadays also. Now you can see in this diagram, let us go with the constructional features of this cupola furnace. From the bottom we'll go for the top. Okay, now here you can see there is a prop bar is there, and these are the legs of that cupola furnace. Okay, and over here there is a hinge is been given, and this is a dumping door. So see, this door can open over here in this direction. Okay, when it has been closed, when it has been closed, okay, when this door is closed in the direction, at the bottom they have giving the proper bar support. Okay, by the help of this hinge the doors are open and closed at the bottom. So this is a bottom base of this cupola furnace, and these are the legs we can call as a stand. Okay, it may be of the metal or the construction has been done for the standing of this cupola furnace. Okay, now this body of this furnace is a steel tube or an hollow steel tube. Okay, it may be 15 to 20 feet. Okay, 15 to 20 feet height. Okay, so above from the normal height of an any individual person. Okay, so big height is there of this furnace, and inside this hollow tube, so there is an fire bricks have been involved. Okay, so this is how the outside construction of the cupola furnace is there, and you can see at the top over here there is a charging door. I will explain what is the charging door and how it is. So this height, okay, at the top there is a charging door, and for this charging door there are the ladle or the saddle is been ladle is been prepared. Okay, or this there is a small metallic fabricated staircase is been used for the laborers or the operators to charge the furnace. Okay, now so above this door there is a sand is been placed at the bottom. Normal sand is been used at the top of this door. Okay, normal sand is been rammed on the top of the door. On this normal sand the wood is been placed. I will tell the working how it is been done. Okay, now I will tell the simple construction over here. There are the slag holes are there. You know what do you mean by the slag? The impurities which floats on the upper surface of the molten metal that are been removed by the slag, and this is a tapping hole from where the molten metal is been coming out. Okay, now here there are the two holes are there, that's are the wind holes. Okay, from the atmosphere whatever the oxygen is there that can enters into the furnace for the combustion purpose, for the burning of the fuel. Okay, now over here you can see there is a charging door is there. This door is there from where the different layers of flux, iron and the metals are been kept, and this is what the chimney. So see, in the exam they may ask the question in such a way: with the sketch explain the construction, working and different zone of the cupola furnace. What they may ask, three things you have to write. Construction is very important in each of every furnaces. Okay, where the furnace are being used you have to write the construction. Okay, then the working. Okay, in cupola extra thing is that zones, there are three zones are occurring in the cupola. Means what? The zones are the area where the different process are happening in this cupola. Okay, okay, for the melting of an metal. Okay, that also we are going to study that particular different zones. You have to explain each and every zone, how in what happens in the well zone, what happens in the combustion zone, reduction zone, melting zone and preheating zone. So what are the things happening over there, that everything you have to explain each and everything. Okay, now this is the simple construction what I have explained to you all. Okay, now let us go with the working. So in the working of the cupola furnace there are 1 2 3 4 5 process are been happening. First one is the starting of an cupola. Second one, charging of an cupola. The cupola has to be charged starting. This cupola has to be start before the cupola the metal has to be melt. It has been started before, it takes a longer time. Then afterwards charging of cupola is been done. Okay, then third one is an melting. Fourth one is an tapping a slag and the molten metal, and fifth one is an drop down the bottom. Now let us see how the operations is been carried out and the work is been carried out. Now you can see over here there is a sand. Okay, these doors are been closed, and over here at the bottom there is a sand is there placed. On this sand a small small wood pieces, soft and the dry wood pieces are been placed on this sand. Okay, a small wood pieces are been placed on this sand. Up to where it has been placed, up to the well zone, up to this well zone the wood is been placed. Now after wood is been placed, the wood is been ignited. Fire the wood has been start fired over there. Once the wood has been ignited, the fire is started, the inner surface of this cupola is been preheated. Okay, when it is been preheated, whatever the contaminate on the walls, okay, inside the cupola will be removed out, and the gases which are inside the cupolas may also come out due to the pre-ignitions. Okay, then what is the next step is a charging of an cupola. What do you mean by the charging of cupola? Just putting and raw material inside the cupola to that to be melt. Okay, that is called as an charging of an cupola, of an furnace. Okay, but in the cupola there is an appropriate charging method is to be used for melting the furnace. Okay, keep in your mind, just putting in a copper, just putting in cast iron in the furnace and allow the fire melt it, okay, then pour it. So no, that happens in different furnaces, but in the couple of furnaces it doesn't work in such a way. The charging is a systematic method is there. On that systematic method only you have to put the charge inside. Charge means what? Whatever the raw material you are going to melt inside. Okay, keep in your mind. Now the charging how is to be done. So see over here there are three things are been placed in the cupola for the charging. So what are the three things? First one is an coke. Coke, what do you mean by the coke? The coke is an just like in charcoal, it is used for the combustion of an metal, for melting a metal, or for uh, producing the heat. Okay, the coke is been placed, you can see in this diagram one layer of an coke is been placed. Then the flux is been added. What do you mean by the flux? The flux is nothing but the contaminants which use to melt the metal over here. Okay, so the usually the limestone, okay, the limestone, what do you mean by the limestone? uh, chuna, okay, in simple languages chuna is called, okay, which has been eaten in the uh, leaves for the insects. Okay, limestone, the limestone, first a layer of an coke, then second layer of an limestone, that is called as an flux. Over here you can see in the dark line there is an flux limestone. Okay, it's commonly used in the cupola. Otherwise you can use sodium chloride, calcium carbides, okay, and fluorospar. So these are the different types of flux, but commonly used nowadays are the limestone. Each and every furnace is there because it is easily available everywhere, used as an flux. Now the third layer is an metal. Okay, after finishing all these layers in appropriate ratios, that is an 8 raised to 1, okay, either iron to the coke. Okay, if the 8 percentage of the iron you are using, 1 percentage of the coke is to be used. Sorry, 8 percentage of the coke you are using, 1% of the iron you have to use. Okay, and the weight of the flux is 1 ratio fifth. If the weight of the coke is 5 times than the flux, like this way the ratio is to be maintained for layering the different this metal, flux and coke. Then once again you have say after the metal is completed, then once again the coke, flux, metal, coke, flux, metal. Like this way, in this method the different layers of the coke, flux and the metal is being charged in the cupola furnace by this charging door. Okay, this charging door is at the top of the cupola. The laborers lift it in an vessel, boring on his head, okay, and lift it. Otherwise the lift are been also used for charging purpose. Okay, so this is at the top, near about 15 to 20 feet from the top the charging door is been placed. Now the melting, how does the melting starts? So see over here the fire is already placed on the wood. Okay, then after this fire transfers the heat to the coke. Okay, from the help of this coke what happens, the flux starts to melt. Okay, and the main use of the flux is to remove the impurities from the molten metal, remove the impurities from the molten metals. Okay, for that reason the flux is being used. From the flux starts to melt and it allows the heat is transferred to the metal and the metal starts to melt over here. Like this way the different layers are been, after melting this metal one by one the layer has been pushed in a downward direction. Okay, once the cupola is been charged up to this top level, the charging is been stopped until the complete metal melts in the cupola. No extra charge of the layers are been put continuously during the melting process. Okay, the melt starts over here. Once the wooden ash has been completed, then the molten metal is collected over here. Okay, molten metal is completely collected over here and the cold ash are being collected at the bottom. Above that upper surface the molten metal is collected over here. Then next step is tapping a slag and the molten metal. Now you can see over here there is a hole is there from which the above floating slag, okay, that's how the impurities which has been removed by this flux, okay, that has been removed out from this slag hole. Okay, that has been removed out by the slag hole. Just this tap is been opened, whatever the slag is there at the top is been coming out. Okay, the molten metal is floating below the slag hole. Then afterwards what happened over here, once the slag is been removed, over here there is a tapping plug is there. Okay, this tapping plug is made of an clay. This tapping plug is been opened from this side. Okay, and whatever the molten metal is there starts to flow through this tap hole and it is been collected into a cup, that is a crucible cup. Okay, and it is been carried out to the pouring section, that is where the molding box are there. Okay, so this is how the simple working of the cupola furnace. Okay, now last step is in dropping down the bottom. Once the molten metal is been finished inside the cupola, okay, so whatever the coke ash and the wood ash is collected on the up top surface of this sand, okay, that has been removed out. How it has been removed out, this popping bar is been carried out. Okay, is been removed. When it has been removed, so this door is been opening. Okay, this door is been opening and whatever the wood and ash are there, that's are coming down. Okay, that is been filled on this bottom of the surface. Okay, after once it has been completed, then the cupola is ready for the next charge. Okay, this is how the cupola furnace working is been carried out. Now let us see the different zone which occurs in the cupola and what are the uses of the different zone and what happens. So this is an well zone. So this area, okay, is called as an well zone, where the molten metal and the slag is there, complete liquid metal and the slag is there, that is called as an well zone. Why it is called as an well zone? The well zone is a proportional situation between the ramp sand from the bottom just below the bottom edge of the tutor. So here there are the two holes are given, they are called as a tutor hole. Below that, from the bottom of the sand, from this bottom surface of the sand to the tutor hole, so that area is called as an well zone. What happens in this well zone? Only the liquid which is liquid metal which is melted from the top is collected in the well zone and the slag is being floated on the upper surface of the well zone. So this is what the well zone is been happening. This is how the well zone is been occurs in the cupola, and the temperature in the well zone is near about 1500 degrees Celsius to 18050 degrees Celsius. Okay, this thing you have to keep in your mind. Okay, so what are the chemical reaction occurs over here? Over here the carbon dioxide plus oxygen release the carbon monoxide plus heat. Okay, so these are the chemical reaction that we have to write in the explanation of the well zone. Okay, now this is the combustion zone. Now next you can say I will like to change the color over here, yellow mark is there. So this is what the combustion zone. So what happens in the combustion zone? In the combustion zone, name itself indicates that the combustion is been taking place. Now you can see over here the heat. Now in the blue line I will tell you the heat is been transferred by the wood at the top side, okay, which makes this charcoal, that is an coke, to combust or to burn or to produce an heat over there, okay. Has the fire is been passed to this over here, the combustion is been occur. Combustion means occur means what? The coke is undergoes the combustion and the heat starts to reduce over there, okay. Once the heat starts to reduce over there, it transfers the heat to the flux. From the flux it goes to the metal over here, and over here you can see the reducing zone is there. What do you mean by the reducing zone? The reducing zones are the protecting zone is the portion located from the top of the combustion zone to the coke bed. In this zone, some of the hot gases, that is the carbon dioxide gases, moving upward through the hot coke and get to reduce the carbon dioxide in a downward CO2 occurs, though this reduction in the atmospheric charge. So see over here there is a wind box is given to the reducing zone. So from over here the combustion is occurring. When the combustion is occurring, this reducing zone means what? Has the charcoal is been burned, it's converted into an ash. When it's converted into an ash, okay, it starts to reduce over there, it starts to come down, okay. But the heat is transferred to the melting zone. As the heat is transferred to the melting zone, the flux and the metal starts to melt continuously, okay, melt continuously. So this things happens in the melting zone. The proportion location just above the coke bed, okay, just above the coke bed, just above the coke bed, the top of the metal iron is called as an melting zone. This is called as an melting zone. The metal starts to melt in this zone and trickles lights down through the coke bed, okay. Trickle lights means what? By we can say no, by the dropping. So have you seen any of the in your house, if there is a slab leakage is there, okay, the concrete slab of an house, if there is a leakage, how the droplets of the water is coming during the rainy seasons, okay. So like this way only the metal starts to melt from the small gaps of this coal. For small drops of the metals is been dropping, small drops of the metals are been dropping inside and collected into an well zone like this way, okay. Small drops of the metals are been passing through the charcoals and collecting a metal zone. So this is a zone where the melting zone is occur, and this is a preheating zone. Preheating zone means what? Before going for the melting, it is been preheated, advancedly heated. Once this layer is been completely melted, it's come down, okay. Then this before during the melting time of this layer, okay, this whatever the top layer is there is been advancedly heated. Advancedly heated means what? Continuous the heat is supplied over there. Once it comes down, that heat is been increased, okay, from eccentric to decentric manner. Then from the decentric to eccentric manner the melting process is carried out, okay. So these are the different zone which are been uh, conducted in the cupola furnace, okay. So during the examination you have to write the explanation. This is a perfect diagram, you have to draw this diagram, as well as you have to write the different zone explanation, working, and the construction. These three things are very important as per your exam point of view. When they ask with a neat sketch, draw the construction and features of the cupola furnace, okay. I hope you have understood. If you are having any doubt, you can ask me. Sanket, Pritam, any doubt? Cupola furnace, Saurabh, you are having any doubts regarding this one? Do you understand that cupola furnace? Pritam, ತಿಳಿತೇನೋ ಪ್ರೀತಮ ಪ್ರೀತಮ್ ಪ್ರೀತಮ್ any doubt regarding Cupola furnace? Okay, so I have completed all the five models. Okay, just I will take the revision. If you are having any doubts or regarding the concept, please comment in a WhatsApp group. So I will take that particular topic and I will start with the explain in the next classes. Okay, so I will wind up the class today over here only. I am having some network problem. I hope I have completed this couple of furnace. Okay. Okay. Thank you for joining.